Yes, we'll continue with Unit 3 in today's class, where we had stopped in previous class on Unit 3. I think we were discussing multiple register transfer load stored instructions, right? What are the applications of multiple register transfer instructions? There are three applications which we had listed. One, to copy the content of one block to another block. Another application is to save and restore the context. We can make use of multiple register transfer load store instructions. And one more operation is stack operation. So these are the three applications which we had listed on multiple register transfer. So we are done with single register transfer load store instructions. So before to that, we had listed three types of load store instructions. So what are the three types of load store instructions we had listed at the starting classes of load store instructions? One is single register transfer load store instruction, multiple register transfer load store instruction, and swap instruction. So these are the three instructions which we had listed. We have completed single register transfer load store instructions, the indexing method supported, as well as the addressing mode supported with respect to single register load store transfer. Okay. Then we were discussing multiple register transfer. In that, we have seen the applications of multiple register transfer, that is to copy the content of one block to another, to save and restore the context, and the stack operations. So out of which we have completed two applications. One is to copy the content of one block to another one is to save and restore the context. So how to make use of load multiple and store multiple instructions to perform the operations that we have seen. Okay. So in today's class, we'll be discussing stack operation, which makes use of multiple register transfer load store instructions. And try to recall the addressing modes, whatever we had discussed on multiple register transfer. The four addressing modes which you can use, it is increment after, increment before, decrement after, and decrement before. So these are the four addressing modes we had listed. Now in today's session, we'll see the stack operations, that is push and pop operations, how actually this load multiple, store multiple instructions are used for performing stack operations, that we'll see, and what addressing modes are supported for stack operations, that we are going to list out, and we'll see with example each of those operations. Okay. As I told, ARM architecture, it uses load store multiple instructions to carry out the stack operations. You know the stack operations supported. It is push operation to insert the data to the stack, and pop operation to retrieve the data from the stack. So stack means it is a memory space where we are going to write the data, from which we are going to retrieve the data. So that means how actually push operation is implemented in ARM architecture, and how pop operation is implemented. So coming to the pop operation, popping the data from the stack means it is removing the data from the stack. So which instruction is used? Is it load multiple instruction or store multiple instruction for retrieving the data from the stack? Which is the instruction we have to use for performing pop operation from the stack? Which instruction?
Load.
Load, right? Load multiple. So LDM instruction I have to use. In addition to that, what suffix we have to give, which addressing mode we have to give, that we'll discuss. So just remember, pop operation is nothing but removing the data from the stack, and it uses load multiple instruction. Since we need to retrieve, load means it is fetching the data or reading the data from the memory, which is the pop operation. Coming to the push operation, which is nothing but writing the data onto the stack, it makes use of store multiple instruction. That is, STM instruction is used for push operation. So before proceeding with the addressing modes supported or for stack operations, okay, we need to discuss few terminologies with respect to stack. So that is, we need to first see what actually you mean by ascending stack and descending stack, empty stack and full stack. So first we'll discuss these four terminologies. After that, we'll be discussing addressing modes on to perform stack operations, right? So stack can be either ascending or descending. For indicating that in the addressing mode, we'll be using these letters. A indicates it is ascending stack. D indicates it is descending stack. Okay, stack can be either ascending or descending. So what do you mean by ascending stack, and what actually you mean by descending stack? So ascending stack means stack grows in the order of increasing memory address. So stack will be growing from lower address to higher address. If it is so, then such a stack is called as ascending stack. Okay, ascending stack grows towards higher memory address. So from lower address to higher address, the stack grows. So that is called as ascending stack. So then what do you mean by descending stack? That means stack grows from lower address to from higher address to lower address. So that is called as descending stack. If stack is growing in the order of increasing memory address, it is ascending stack. If stack is growing in the order of decreasing memory address, then it is called as descending stack. Hope this is clear. Ascending stack, it grows from lower to higher address. Descending stack, it grows towards lower memory address. That is from higher to lower, the stack grows, right? So this is about ascending and descending stack. So there are two more terminologies, that is full stack and empty stack. So what do you mean by full stack is, before to that, you should know the special register that is used whenever you are performing stack operations. So which is that special register which will be pointing to the top of the stack? It is stack pointer. So whenever you are dealing with stack operations, that is either the push operation or pop operation, which register is to be used? It is SP register, that is stack pointer register. Okay. So in case of full stack, and we'll be using the letter F to indicate full stack and letter E for empty stack. In the addressing mode, we'll use A for ascending stack, D for descending stack. Empty stack, if it were to be, then we'll be using letter E. If it were to be full stack, we'll be using letter F. We'll be suffixing these letters to the instruction LDM and STM. Okay, where LDM for pop and STM for push operation. So what actually mean by full stack is, the stack pointer will be pointing to the last element inserted. Okay, that is full stack. So where SP will be pointing to in case of full stack, it points to the address that is last used, or it points to the address where last data item is inserted. So that is full stack. So that's what I've mentioned in this point. When a full stack, in bracket I've given F, this is what the letter will use to indicate full stack, where actually stack pointer will be pointing to the address that is last used or full location, meaning SP points to the last item on the stack. Okay, this is about full stack. What about empty stack? So empty, and before to that, so if it were to be full stack you are using, okay, if you want to insert a new data into the stack, then what we have to do is, we have to update the stack pointer first, and then we need to go for inserting the data. That is, we need to perform the push operation. So this is about full stack. Okay, if we are using full stack, what is the updation we need to do to the stack pointer? So that depends on whether you have considered ascending stack or descending stack. So if you have taken ascending stack to perform push operation, okay, we need to first increment the stack pointer and then we need to insert the data. If it were to be descending stack you are using, in that case, we need to first decrement the stack pointer and then we have to insert the data. Okay. At any point of time, if we just check the stack pointer, in case of full stack, it will be pointing to the last element insert. Okay. This is about full stack. Coming to the empty stack, here the stack pointer will be pointing to the next location where the new data is to be inserted. So that is it, just above the last element inserted, to that address SP will be pointing to. So that is about empty stack. See, when an empty stack is used, the stack pointer points to an address that is the first unused or empty location. That is, it points after the last element on the stack. That means immediately it points the next location after last element is inserted. That means whenever you are going for inserting the data, you need not update the stack pointer first. Already it is pointing to the empty location. We can first perform the push operation and then we can update the stack pointer based on whether you have considered ascending stack or descending stack. So if you have considered ascending stack, then after inserting the data, we'll perform increment operation on the stack pointer. So if you have used descending stack with an empty stack, okay, in that case, first we'll insert the data, then we'll decrement stack pointer by the value, say 4. So since each data is 32-bit here, it will be decremented by 4. Okay, this is about empty stack. Hope these four terminologies are clear. Ascending stack, descending stack, full stack and empty stack. A combination of these, whether you are selecting ascending or descending, full stack or empty stack. So with these four letters, we are having four different addressing modes for stack operations. So as you had for the multiple register transfer, that is increment after, increment before, decrement after and decrement before. Here with respect to stack, depending on whether you are using ascending or descending stack, full stack or empty stack, so you need to select one of these two. So considering these four, the combination of letters what you'll get, that forms the addressing modes for stack operations. So that have listed in this table. Okay. And actually these are the addressing modes, load store multiple addressing mode aliases we say for supporting the stack operations, meaning increment after, increment before, decrement after, decrement before. These four addressing modes for multiple register transfer we already seen. Another name for same operations you are finding with respect to stack operations. Okay, that's why we say it as aliases. So these are the addressing modes for stack operations supported. And what is the equivalent increment after, increment before addressing mode supported? That also you are seeing in this table. Let us just try to analyze this table. Okay. So what are the addressing modes for stack operations supported? It is full FA, EFD, EA, ED. Okay, these are the four addressing modes. What FA stands for? Full ascending. Already you know the meaning of a full empty stack, ascending, descending stack. Now we shall try to analyze these instructions with respect to stack. Okay. In the second column, what you are seeing is full ascending. FA stands for full ascending. FD stands for full descending. EA stands for empty ascending. And ED stands for empty descending. Okay. These are the four addressing modes supported. And just see the fifth column here. Fifth column indicates push operation. Okay. So what are the instructions we have written? It is STMFA. So full ascending we have taken. The addressing modes, whatever we have specified in the first column, that we have suffixed to STM instruction. Just observe the fifth column. So kindly go step by step. So at one stretch, if you see the entire table, it may be confusing to you. So just observe, we are talking about push operation on the stack. So if you are performing write operation to the stack, you know which instruction is to be used. It is STM instruction. Hope you all know that. So in the previous slide I told, so store multiple instruction is used to perform push operation and load multiple instruction is used to perform pop operation. Right? So just see the instruction we have used. STM in this fifth column, it is all STM instructions. And in the third column, what you are seeing is all LDM instructions, load multiple. Correct? But for this, we need to suffix the addressing modes. Without addressing mode, you cannot perform the stack operation. You need to select whether it is ascending or descending stack or full stack or empty stack. So that we have to choose through these letters suffixed to the instruction. So if I write STMFA, that means you have chosen full stack and ascending stack. If you are using FD, it is full stack and it is descending stack. So EA means it is empty stack and ascending stack it is. ED means empty descending stack. Okay, based on what addressing mode you have used. So it is the type of stack you have chosen. Hope this is clear. So if it were to be full ascending, so what do you mean by full stack? Full stack means where SP will be pointing to. SP, if it were to be full stack, where SP will be pointing to. Yes? Are you all following? So if it were to be full stack, just see if I'm using F in the instruction in the mnemonic, that means it is full stack. If it were to be full stack, you know, SP, it will be pointing to the last element inserted. Are you getting? Okay. And what is the equivalent STM instruction for STMFA? The full ascending. That means SP is pointing to the last element inserted. If I want to insert a new data to the stack, if I want to push a new data to the stack, so what we have to do is, first we have to increment the stack pointer by 4 and then the data is to be inserted. So what is the equivalent addressing mode I can use for FA? It is IB. Just observe, since we need to first increment and then we need to insert. Since SP is pointing to the last element inserted, first we are incrementing, after that we are performing the push operation. So the equivalent STM instruction for STM FA is STM IB. Okay. So if you are dealing with full stack, just see, for push and pop, we are using the same addressing mode. So if you are using STM-FA, it is LDM-FA you are using. Similarly, STM-FD, it is LDM-FD. So push and pop, the addressing modes used are same, but the equivalent LDM and STM instructions are different. Just see, if you are dealing with full ascending stack, meaning the stack pointer is pointing to the last element inserted. It is full ascending means stack is growing in the order of increasing memory address. It is moving from lower address to higher address. And if this is where stack pointer is pointing to, then what we have to do is, first we need to just delete the data, or you need to retrieve the data from the stack wherever SP is pointing to. Since it is full stack, then we need to go for decrementing the stack pointer by 4 so that it points the next data to be removed from the stack. So if you are using increment before to perform push operation, okay, so what is the equivalent LDM instruction to represent pop operation? It is decrement after. You have used save and restore context instruction pairs, load and store instruction pairs. So that instruction pair you are using here. If it is IB, it is DA, the addressing mode, that is the equivalent addressing mode for LDM-FA. So STM-FA is equivalent to STM-IB and LDM-FA is equal to LDM-DA. Why it is DA, decrement after? Since we are trying to perform pop operation, so already it is a full stack, meaning SP is pointing to the element to be removed from the stack. So first remove the data from the stack and then decrement stack pointer by 4. So that the new top of the stack element you will find. Okay. So this is about STM-FA and LDM-FA. Similarly, if you just consider STM-FD, it is full descending. So how actually we are performing the push operation here? The stack is full, it is full stack we are taking, and it is descending stack. That means stack grows in the order of decreasing memory address. So to perform the push operation, first I need to decrement the stack pointer by 4 and then I need to insert the data. So what is the addressing equivalent addressing mode for STM-FD? It is STM-DB, decrement before. It is full stack, meaning SP is pointing to the last element inserted. It is descending stack, that means stack grows in the order of decreasing memory address. To perform the push operation with this addressing mode, first the stack pointer is to be decremented by 4 and then the data is to be pushed. So the equivalent STM instruction for STM-FD is STM-DB. So if it were to be DB, then you can easily say it is IA instruction, LDM IA instruction, the equivalent instruction for POP, that is LDM FD. So how it is LDM IA, increment after. So that means, so to perform the deletion operation from the stack, so we need to first retrieve the data from the stack wherever stack pointer is pointing to, and then we need to increment the stack pointer by 4. So that's why it is increment after. First, we'll access the data from wherever SP is pointing to, and then we are going to increment the stack pointer. That's why the equivalent addressing mode for FD is, it is IA for pop operation. Okay. In the same lines, you can understand, you can try to analyze EA and ED. So just see, STM EA instruction is used for push. It is empty stack we have considered, and ascending stack. That means stack grows in the order of increasing memory address. The empty stack means SP will be pointing to the location where the data is to be inserted. So first we need to insert the data, and since it is ascending stack, we need to increment the stack pointer by 4. So what is the equivalent STM instruction? You can write for STM-EA, it is STM-IA. It is increment after. Why? It is an empty stack we have taken. So first we'll insert the data or we'll push the data, then we'll increment the stack pointer by 4. So that's why this is the equivalent instruction. So if it is increment after addressing mode for push operation, it is decrement before addressing mode for pop operation. How it is decrement before? How actually it is decrement before? SP will be pointing to the location where the new data is to be inserted. You will not find any data. It is an empty location where SP is pointing to. So to perform the pop operation, first we have to decrement the stack pointer and then we have to retrieve the data. Okay, so that's why it is decrement before. So all these addressing modes I'll show you with examples how actually it works. Okay, so coming to the last instruction, that is the last addressing mode, STMED. This is the instruction. The addressing mode used is ED, meaning empty stack, and it is descending stack. So empty stack means SP is pointing to the location where the new data is to be inserted. So first we'll insert the data wherever SP is pointing to. After that, we are going to decrement the stack pointer by 4 since it is descending stack. Each time you are performing the push operation will decrement. So remember this, if you are using ascending stack, after performing the push operation or before performing the push operation, it is increment operation we are doing to the stack pointer. If you are using descending stack, that means stack pointer will be decremented when you perform the push operation. Whether it is before pushing the data or after pushing the data, that depends on you are using whether full stack or empty stack. If you are using full stack, then first it increments, then it inserts in case of ascending stack. If you are using descending stack, then it first decrements and then it inserts the data. Hope these four terminologies are clear and these four addressing modes. So what is the equivalent STM instruction for ED? It is empty descending. Just say it is decrement after. So first the data is inserted and after that the SP pointer is decremented. So that's why it is decrement after addressing mode used. So and the equivalent LDM instruction is, say for decrement after DA, just replace D with I and A with B, you'll get increment before. So this is the addressing mode you are going to use for pop operation. So that means for SP pointer must be first incremented so that it points to the last data inserted and then we are going to retrieve the data from wherever SP is pointing to. So that's why it is increment before addressing mode used for pop operation and this is the instruction you are using LDM ED. So what is the equivalent instruction? It is LDM IB. So if you are given with LDM FA, STM FA and if they ask you to write equivalent STM and LDM instruction, you should be in a position to write it. Okay, in this table we are seeing all those information. So if you have clearly understood what do you mean by full stack and empty stack, ascending stack and descending stack, you can clearly analyze these instructions. Okay. So remember in general, if I am dealing with push, it is STM instruction used. If I am dealing with pop, it is LDM instruction. Okay. So full ascending means, so it is already stack pointer is pointing to the last data inserted. So we need to first increment and then we need to insert. And if it were to be full descending means, first I need to decrement the stack pointer and then I have to insert. If it were to be empty ascending, then in that case, first I need to insert and then I have to increment the stack pointer. If it were to be STM ED use, then how to perform the push operation? So first I need to insert and then I need to decrement the stack pointer by 4. Okay, this is how push operations can be performed using these addressing modes. So equivalent pop operation, it is same addressing mode you'll be using. Okay, so whatever the addressing mode used for STM to perform the push operation, same addressing mode you have to use for pop operation, but the equivalent LDM STM instructions will be different. Just observe, if it were to be STM IB, the equivalent instruction for push, the equivalent LDM instruction for pop is LDM D. Just replacing I with D and A with B, vice versa. Okay, this is what you need to know with respect to the addressing modes for stack operations. So that's what I've explained in this slide. Okay, this whole thing explained. And one more point you need to know is ARM has specified a standard that is called as ATPCS standard. What it stands for is ARM Thumb Procedure Call Standard. And what the standard defines is how the functions are called and how actually the registers are allocated whenever the routines are called. So how they are going to occupy the memory space. So all these are actually defined in this standard. which is called as ATPCS. So arm thumb procedure called standard. So according to this standard, okay, how actually the stacks are defined is, so they are considered as full descending stack. The full descending stack means to perform the insertion operation, first we need to decrement the stack pointer and then the data is to be inserted. Okay, so that is the STMFT. SDMFT and LDMFT are the instructions which provides this push and pop functions or push and pop operations respectively. So here LDM means it is a pop operation, STM means it is push operation. So as per this ATPCS, how actually the stacks are defined? It is defined as being full descending stack, meaning to perform pop operation, it is LDMFD instruction that can be used, and for performing the push operation, it is STMFD instruction that can be used. So to make you understand how actually this full ascending, full descending, empty and that is empty ascending and empty descending stacks works, I've made few slides. Try to analyze this. First, we'll see the push operation, and the instruction we are considering is STMFA. Okay, full ascending stack. Just see here. This is the starting address I have considered 0000. Ending address I have taken it as FFFF. Okay, and it is, since it is full stack, where SP is pointing to, it is to the last element inserted. Assume some data I have written in general as say some XXX. Some data is there at the top of the stack. So SP is pointing to the last element inserted in full stack. Ascending stack means stack grows in the order of increasing memory address. That is the meaning of ascending stack. Hope this diagram is clear. Okay, SP is pointing to the last element inserted, and how the stack is growing when you perform insertion operation. It is growing in the order of increasing memory address. And just see, these are all empty locations. Prior to this, it is all filled. Okay, SP is pointing to the last element inserted. So now if I want to perform the push operation to this using STMFA, this instruction. So what is the operation performed? Already SP is pointing to the last element inserted. So first we need to perform what operation? This is ascending stack. So what is the updation to stack pointer I have to do? Should I insert the data first or should I update the stack pointer? What should be done first? Here
Increment,
come again.
increment before.
Yes. We need to first increment the stack pointer by 4. So SP gets incremented by 4. At this location, we need to insert the data, push the data. Hope STMFA is clear. It is full ascending, meaning SP is pointing the last element inserted. First, SP is to be updated. Will you increment or decrement? That depends on whether you have taken ascending or descending stack. Since we have taken ascending stack, we'll increment the stack pointer by 4 and then the data gets inserted. Okay, so this is about STMFA. If you are using pop operation with this instruction, if you are performing pop, it is LDMFA instruction you are using for full ascending stack. So this is the representation. Just observe. After performing push operation, just see where SP is pointing to. There is the last element inserted. So now if I want to perform pop, so already SP is pointing to the data to be deleted. So first delete the data. We need to pop the data first. So that is, this data gets popped off, and then we need to decrement SP by 4 so that it points to the next top of the stack. Okay, next data to be removed from the stack. Correct? See, just see push and pop operations performed using STMFA, LDM FA instruction. Hope this is clear. If it were to be STMFA use, increment first and then push the data. So that means, so what are the equivalent instruction you are using? If it were to be STMFA and LDMFA, can anyone tell the equivalent STM and LDM instructions? For this, what is the equivalent STM instruction? STM, just see the instructions I have written and tell the instruction. STM, what we have done first?
STMIB.
Very good. Increment before. This is the equivalent instruction for STMFA. Just see this and tell what is the equivalent LDM instruction for POP. It is LDM. Just replace I with D and B with A, I told. It is
Decrement
decrement
after.
after.
LDMDA.
Yeah, LDM DA. Is it clear? So that means SP is already pointing the last element. First we'll delete this data and then we'll decrement stack pointer by 4. So that it points to the next top of the stack. This is decrement after addressing move, the equivalent instruction for pop. Okay. So that's what I've shown in this diagram. Similarly, if it were to be STM-EFD instruction used, full descending, just see the diagram. Full descending means stack grows in the order of decreasing memory address. That is the meaning of descending. From higher address to lower address, the stack is growing. Each time you perform insertion operation, pointer will be decremented. So whether first decrement operation takes place or after, that depends on whether you are using empty stack or full stack. So here we have considered full stack. Just observe, SP is pointing to the last element inserted in case of full stack, and it is descending stack. So to perform the push operation, what is the first operation to be performed? We need to decrement SP by 4 so that it points to the empty location where the data is to be inserted. After SP is decremented by 4, next we are going to push the data. Okay? This is STMFD. Are you getting? So this is how you can observe stack is growing in the order of decreasing memory address. That is why it is called as descending stack. Okay. So coming to the pop operation, that is LDM-FD instruction. So this is the status of the stack where SP is pointing to the last element inserted since it is full stack. If I say full stack, where SP will be, it will be pointing to the last element inserted. Now I need to perform the pop operation. So first delete the data, that is pop the data, then go for incrementing stack pointer. See here, it is descending stack. To perform insertion, we'll decrement. But here, since it is pop operation we are dealing with, after deleting this data, wherever SP is pointing to, after removing this, so we need to just increment stack pointer by 4, and then you can see that SP will be pointing to now the next element that is to be removed from the stack. This is full stack. So each time we perform push or pop operation, where SP will be pointing to is the last element inserted or the first element to be removed from the stack. You know stack, okay, where SP will be, so it is LIFO data structure. Last element inserted will be the first to be removed from the stack. Okay. And what is the equivalent STM and LDM instructions? I told these are the aliases used, STM, FD and LDM, FD. What is the equivalent STM instruction for this? Just observe these two instructions and tell the equivalent instruction. It is STM only. STM. Decrement first and then insert. Decrement before, right? Correct? It is decrement before. What is the equivalent LDM instruction? LDM. If it is decrement before,
IA.
yes, very good. D replace it with I and B you replace with A. It is LDM IA. Since we are first retrieving and then we are incrementing. It is increment after. Access the data, then increment. Just see the equivalent instruction. If you have clearly understood ascending, descending, empty, full, those terminologies, then you can easily understand the stack operations. Okay. In the same lines, I've made the slides for these two instructions, that is STM EA and ED. Let us see in this slide. First EA. Just observe empty. It is empty stack. Meaning just observe where SP is in case of empty stack. It is pointing to the next location after the last element is inserted. This is where stack pointer is pointing to. Empty stack it is. Okay. So now we need to perform the push operation. And since it is ascending stack, stack grows in the order of increasing memory address. From a lower address to higher address, the stack grows. Already SP is pointing to the location where the data is to be inserted. So first we'll insert the data. That means we'll push the data to the stack wherever SP is pointing to. And since it is ascending stack, we'll increment the stack pointer by 4. Okay, this is what the operation will perform. If it is STMEA, first push the data since it is empty stack. Then since it is ascending stack, we need to increment SP by 4. Okay. So now So coming to the pop operation, LDMEA instruction that is used. So this is where SP is pointing to. This is the empty location. That SP is not pointing to the data that is to be removed. So first what we have to do, we have to decrement SP by 4 and then we need to pop the data. Just see, this is the first step we need to perform, decrement SP by 4 so that it points to the last element inserted, then go for popping the data from the stack. Okay, so this is LDMEA instruction. So STMEA, just see what are the two operations performed, and for LDMEA, what are the two operations. So now you can easily guess the equivalent STM and LDM instruction by considering these two. Can you tell the equivalent STM instruction? STM,
STMIA.
very good. It is first push and then increment. It is increment after. And what is the equivalent LDM instruction?
LDMDB.
Very good. It is LDMD. Clear? So this is one more set of instructions you are using to perform the stack operation. Yes, this is STMEA and LDMEA instruction. One last pair we'll see, that is STMED and LDMED instruction. Just see here STMED, where it is descending stack you have considered. That means stack grows in the order of decreasing memory address. Empty stack meaning stack pointer is pointing to the empty location. That is the date. It is pointing to the location after the last element is inserted. Okay. So now to perform the push operation, we need to first insert the data, and then what is the operation we need to perform? Stack is growing in the order of decreasing memory address. Should I increment stack pointer or decrement stack pointer? It is descending stack. You know that since it is empty stack, I need to first perform push operation. Correct? I need to first insert the data. After this, tell me whether I need to increment SP by 4 or decrement SP by 4. This is push operation.
Decrement.
Yes, very good.
Decrement.
Decrement. So decrement SP by 4 since it is descending stack. Here. So now coming to the pop operation, LDMED, empty descending. So this is the stack status. Just observe SP is not pointing to the last element that is inserted. To the next location it is pointing to. So first what I need to do, I need to update the stack pointer. Should I increment or decrement SP? Just see the diagram.
Ma'am, Increment. decrement after.
Is it decrement? See, we are performing pop operation. Push and
Ma'am,
pop
pop.
both will not be decrement. If you are using decrement operation in push, it will be increment in pop, right?
Ma'am,
You know how
increment
stack
before.
goes. Yeah, you know the usage of your stack, right? So you are using in DS top pointer. It was increased when you are when you are trying to insert, and it was being decremented when you are performing a pop operation. So while in case of push, if the pointer is decremented, it cannot be the same when you are performing pop operation. So it is increment, right? See, in push it is decrement SP by 4. In case of pop, first we are going to increment SP by 4 so that it points to the last element inserted and then go for popping the data. Okay, so this is LDM ED. So with these two statements, I think you can easily guess the equivalent STM instruction. So it is STM, push the data, then decrement. What is the addressing mode?
And STMDA.
Yeah, decrement after. Very good. If you have easily understood this the instruction, no need of analyzing any other statement. So just replace D with I and A with B. You can write for this. It is LDM. The instruction is LDM IB. Since we have just observed the diagram, we first incremented the stack pointer. This is increment before, then delete the data from the stack. That's why the equivalent instruction is LDM IB. So the same instructions you are seeing as a summary in that table. So what and all the push instructions supported, what and all the pop instructions supported. These are all the aliases for load store multiple instructions. What are the equivalent load store multiple instructions for pop and push? That's what you had seen in the table. Hope this is clear. Shall we go through the examples?
Yes, ma'am.
Yes. Just see this example with respect to the instructions, how actually we can make use of push and pop. Only push I'm showing, all the push operations, then the pop will see. Just see, this example is to push the registers onto full stack using STMFD. It is full descending stack we are considering. So this is the precondition we have taken. R1 is having the value 2, R4 is having the value 3. Push means we need to push the or save the content of these registers to the stack. And SP pointer status we have taken as 80014. Okay, just see the memory map on the right hand side to show the precondition for STMFD. Okay, so SP is pointing to this location. Since it is full stack, this is the last element inserted. We are assuming 0b is the last element inserted since it is full stack, and it is descending stack. That means to perform the insertion operation, since it is full stack, we need to first decrement the stack pointer and then the data is to be inserted. And just observe how the stack is growing. Is it growing from higher address to lower address or lower address to higher address? How the stack grows?
Higher to lower.
Higher to lower. So which are the registers I'm using? Just see the instruction I've considered: STMFD, SP not, comma R1, comma R4. These register contents I need to push to the stack. Okay, this is load multiple, store multiple instructions. You know what is the syntax of writing the instructions. Since we are dealing with push, it is STM instruction we have taken, and pointer register to be used is SP. We need to update the stack pointer after the operation, so not symbol is given. R1, R4 are the registers given in the list as second operand. Okay, so now since it is the stack is growing in the order of decreasing memory address from higher to lower, can anyone tell at address 80010 which register content will be saved? Is it R1 register content or R4 register content? It is full stack. SP gets decremented and then the data is inserted. Okay, SP is having the 80014. So after decrementing SP by 4, it will be 80010. Can anyone tell which register content will be saved? I told one important note while we were discussing
R4
load multiple.
register content.
Which register?
R4.
Very good, very good. R4. If you're moving from higher address to lower address, remember higher register to lower register, accessing takes place. Okay. So R4 register content will be pushed to this location. Then SP is decremented by 4. SP will be having the address 800C to this address. Next lower register, that is R1 register content, which is 2, that will be stored. So if you just see the location 10H, you'll be seeing the value 3, and if you see the location C, you'll be seeing the value 2. Now, what is the final address held in SP? It is 800C. With the post condition, register content will not be affected since it is push operation. Registers are the source operands. Their content will not be altered. SP, it is updated to 800C. The post condition diagram also I have shown here. Okay. Just say the memory content. 80010 is having R4 register content and 800C is having R1 register content. See the stack pointer. See the stack is going in the order of decreasing memory address since it is descending stack. Full stack meaning SP is pointing to the last element inserted. To perform the insertion, first SP is decremented and then the data is inserted. Okay. If it is asked to explain the stack push and pop operations, any of the instruction pair you can consider. With this diagram, you can easily explain. You can take some register content, you can take the SDM instruction, okay, any set of registers you can take. Memory map for that you can easily show. Okay, this is there actually in your textbook. Only for one or two they have shown. Before to that, just to make you understand how actually all these addressing modes work, I prepared those previous slides. Okay, what is required is these diagrams. Okay, hope it is clear. Similarly, to push the registers onto empty stack, empty descending stack. This is the stack status. See, R1, R2 is having 2, 3. SP is having the address 80010. It is empty stack. See, stack pointer is pointed to the next location after last data is inserted. It is empty descending. So, what is the first operation to be performed? If this is the instruction used, STMED, empty descending, SP not comma R1 comma R4. Can anyone tell what is the first operation performed? Can you tell the memory map after execution of this instruction? It is
Ma'am,
descending stack.
decrement after for push
Yeah,
operation.
decrement after. So what will be stored at address 80010? What gets stored? We are going in the order of decreasing memory address.
R4.
R4. Good. R4 content. So since already SP is pointing here, we'll store R4 content at address 80010. Then SP gets decremented. It is decrement after, as you told. Then R1 register content is stored. So after that, what will be the status of SP? What will be the updation to SP? 8008. 80008 will be the SP content since it is decrement after. First insert the data. Since it is moving from higher address to lower address, registers are accessed in this order, higher register to lower register. R4 content is saved at address 80010. Then SP is decremented by 4 at 800C. R1 register content is saved. Then SP is decremented by 4. Since it is decrement after. So final address you find in SP is 8008. And the source register contents will not be altered. If you see the memory locations, see, these are the data you find at these addresses. 80010 it is 3 and 800C it is 2. Okay, hope this is clear. Have you all followed till this? These two examples, is it clear?
Yes, ma'am.
Okay,
Yes, ma'am.
so it is time up. Let us stop here. I'll continue in the afternoon class. Okay. Okay.